Hello everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science, Nirmalar Institute of Technology. Today, we are going to discuss about Unit 5, that is graphs and trees. So, in this, the overview of presentation today includes introduction to graphs and also types of graphs. So, first, let us understand what is meant by a graph. So here this graph theory, we can say that it is a core branch of mathematics. That too, it is a core branch of discrete mathematics which is focused on studying the relation between the objects. And this graph theory was born in the year 1736 and it was discovered by the famous mathematician and his name is Euler. And how he discovered is so by using the Königsberg bridge problem. In the ancient days, so they used to have one bridge problem. The problem name they have given is Königsberg bridge problem. So because of that, why? Because as he solved this Euler Königsberg bridge problem, so that's why they have given him the father of the graph theory as a name. So as he solved this Königsberg bridge problem, that's why the people of that person, ancient history, so they have given the name as father of graph theory. So now graphs, especially trees and binary trees. So especially trees and binary trees, we can see that they are widely used in the representation of data structures. So this is a very important concept we can say as we are going to see in the data structures concepts also. So now let us see here the basic concepts and notations. What are the basic terminologies of the graph? So what are the types of graphs? And in the next session, we are going to see about the degree of the vertex also. So first let us see here what is a graph. So a graph, capital G. Here I am representing the graph as capital G. It is a pair of set V comma E. So here V is nothing but what here? Vertices and E is edge. So a graph G is a pair of set vertices comma edges. So where V is nothing but set of vertices, these vertices, the other name for vertices is called nodes. And E is set of edges, the other name for edges is here lines. So V of G means set of vertices in G, E of G means set of edges in the G. So here always we are not specifying here it is a graph, but whenever we see here G, capital G, this is called a graph. Now, mod V of G, so is nothing but number of vertices in the graph G, and we can also call it as order of G. And in the same way here, E of G, mod E of G, number of edges in the graph, which is nothing but size of G. So here if you observe, graph is nothing but always a combination of vertices and edges. So here if you observe, this is figure 1 I have taken here. So where we are representing here with vertices, vertex 1, vertex V2 and this is vertex V3 and this is vertex V4. So and these vertices are connected with edges. So this is V1 to V2 is one edge, V2 to V4 is one edge, V1 to V3 is one edge, V3 to V4 is another edge. So in the same way we have connected from V1 to V4 also. So now if you observe here, this total figure, it is in the representation of combination of vertices and edges. Then I can say that this is called a graph. So I can represent this with the capital G. So now V of G means the set of vertices. So what is V of G here? Set of vertices, how many we have? What are those? V1, V2, V3, V4. These are the set of vertices we have in the particular graph. In the same way, E of G. So the set of edges. So what are the edges we have here? E1, E2, E3, E4, E5. So these are the set of edges we have here. So now here if you observe, these are the set of vertices and these are the set of the edges here. Now mod V of G. So what is mod V of G here is the number of vertices in the graph, which is nothing but order of the graph. So what are the number of vertices we have here? 4. And this one we can call it as order of G. And E of G, mod E of G is So 3, 4, 5. Total 5 we have. So order of G here, edge of G here, which is nothing but we can call it as size of G. So here always we can say for this particular graph, mod V of G is 4, which is order of the graph here is 4, order equal to 4, and edge of G, which is nothing but number of vertices in the graph, number of edges in the graph is 5. So we can say that size of this particular graph is equal to 5. So in this way we can represent the number of vertices, which is nothing but order of the graph, and size of the graph, number of edges in the graph. So this is what is graph and number of vertices and edges. Now let us see the types of the graph. Undirected graph. So what is meant by this undirected? So which does not have any directions. For what? For the graph. In a particular graph. So as we already discussed here, graph is nothing but combination of vertices and edges. So which is nothing but always will have edges and vertices. Now here I don't have any direction. So direction means how I can give direction in the graph here. If I am giving some specific arrow that vertex has to move only that side from V1 to another vertex which is called, let us suppose, V2. So then I can say that here, so this V1 has to move only that direction but not to the other direction. So but here if I don't mention any direction, the type of directions in the graph, then I can say that this is called undirected graph. So a graph which does not have any directions for the edges is called undirected graph. Now directed graph, which is nothing but if all the edges, so here in the graph you have to observe for all the edges it should not have direction, then only we can say it is called undirected. So for the direction here, so all the edges must contain here directions in whatever the direction it has to, but it has to move. Some specific arrow has to be mentioned in the graph. Then only we can say that it is called directed graph. Now if you observe this example, so here we have V1 and here V2 and this is V3 and this is V4. So now V1 is moving towards V2. V1 is again moving towards V4 also. And this V1 is moving towards V2 is nothing but we can say that it is going outward. So outward direction we can say. So outgoing it is. And even for V2 it is called incoming direction. So in the same way V1 to V4 means V1 is going outward, which is nothing but outgoing, and V4 for the V4 it is incoming. So like this if you observe from V2 to V3 is direction is there, from V4 to V3 also direction we have here. So like this for every edge we have directions with the arrows mentioned here, specific arrows. Then I can say that this is called directed graph. Now in also we have loop. So what is meant by loop? An edge ran from a vertex to itself. So let us suppose here I have vertex A, this is vertex B and this is vertex C. Now the vertex A is having edge to B, A to C and B to C is also edges we have. But along with this edges we also have another edge from vertex A where it is drawing and moving towards with only again A. Means it is pointing towards again, it is moving with only A. Then I can say that it is called a loop. Means the edge which is drawn to itself to the vertex. An edge drawn from the an edge is drawing from here vertex A and again it is pointing towards the same vertex. Then I can say this is called a loop. In the same way we have mixed groove. If some edges in a graph are directed and some other are undirected. So as we have seen here just now what is directed and undirected. So directed means which have directions, undirected is which doesn't have any directions. But in a graph, if some edges are having some directions, if some other edges are not having directions, so that is nothing but we can say it is called mixed graph. So let us suppose here this is one graph. So where I have the vertex V1, vertex V2, vertex V3 and vertex V4. Now let us suppose here I am giving direction here V1 to V4 and I am giving direction to V3 to V2. So now only for these edges I have direction, but other edges I don't have any direction. So if these edges have direction, that is called directed graph. Doesn't have any direction, these are called undirected graph. So this is everything is existing only in the one graph. Then I can say this graph we can call it as, the other name it is called mixed graph, where it is a combination of both directed and undirected graphs. So next we also have adjacent vertices. Any pair of vertices which are connected by edge in a graph are called adjacent vertices. So any pair of vertices, let us suppose here I am taking V1 and this is V2. So these two vertices are connected by one edge, an edge in a graph. Then I can say this V1, V2 are called adjacent vertices. Why? Because these vertices are connected by only one edge. So that's why side by side they are there. That's why it is called adjacent vertices. In the same way, if I draw like this here, V3 and this is V4. Now if we observe, V1 and V2 are called adjacent vertices. V2, V3 are called adjacent vertices. V3, V4 are adjacent vertices. And you also V1, V4 are adjacent vertices. So these are all adjacent vertices only here. So, but if you observe, V4, V2 are not adjacent vertices. But if I draw like this V4 to V2, they are also called adjacent vertices. So in the same way, we have parallel edges. So what are parallel edges? If two edges have the same endpoint. So let us suppose here I have taken one figure where I have A, B, C, D, and if two edges are having the same endpoints. Now if you observe, this is only one edge I have, and B to D is one edge, A to C is one edge. Now if we observe C to D, we have two edges, but we have only one pair of vertex. So one pair of vertex is connecting with two edges, and those two edges we can call it as parallel edges. In the same way, we have null graph. So what is null graph is, a graph is said to be null graph if it has no edges. So which is nothing but what? We know that a graph is a combination of both vertices and edges. But if you have only vertex, which is nothing but V1, but it is not having any edge. So combination of vertices and edges itself is called a graph, but if I don't have any edges, then I cannot say that it is a graph, as edges are missing, as we have only one vertex. So that particular graph we can call it as null graph. In the same way, we have simple graph. If a graph is undirected and does not contain any loops, then the graph is called simple graph. So if a graph is undirected, so we already know that graph is undirected means which does not have any directions. Along with that, which it does not contain any loops also. So let us suppose here I am drawing one graph here. So where I have the vertex A, B, C, D. Now I can see that this graph is called undirected graph. Why? Because it is not having any directions. Now, and also which does not contain any loops. So loop is nothing but what? An edge which is drawn from the vertex to itself. Now here I don't have any vertex. But if I draw the vertex to itself, this is called loop. So this type of loop should not be there if we want to call that it is called simple graph. So that's why here if you observe this figure, no directions and no loops. And this particular graph we can call it as a simple graph. Now next we have multigraph. So what is meant by multigraph? If a graph which consists of loops and parallel edges, then that graph is called multigraph. So here it should contain the loops, it should contain the parallel edges. So that is what we are calling it as multigraph. So now let us suppose here I have taken one figure. So vertex A, vertex B, vertex C, and this is vertex D. Now let us suppose I have the vertex from vertex A to H, which is called loop, self loop. And let us suppose for C also I have self loops. And parallel edges also we have. So parallel edges are nothing but what? Let us suppose here I am drawing from A to B one more edge. So where these two edges we can call it as parallel edges. Now this particular graph we can call it as multi-graph. So this graph is called multi-graph. So here, so in the same way we have another figure also, where if you observe here, we have the loops here. So for this we have the loop, this one it is also loop, this is also loop. And parallel edges also we have here. So from these 2 points we have two edges, and for these 2 points we have two edges. and for these 2 points we have two edges. So like this, if you observe, we have the parallel edges also. Then we can say that this particular graph is called multigraph. Now next we have pseudograph. So what is meant by pseudograph is a pseudograph consists of loops but not parallel edges. So here a pseudograph means which consists of loops. So here multigraph means both it should contain parallel edges and loops. But here only loops should contain but not parallel edges, and that particular graph we can call it as here pseudograph. So now if you observe this figure here, we have the vertex A and this is B and this is C. Now we have the self loop for A and all edges are there. It is undirected. Okay, fine. So to become pseudograph, so we need to first observe whether we have the loops or not. And it should not have parallel edges also. So then only we can say this particular graph is called pseudograph. Now next we have finite graph. A graph with a finite number of vertices as well as finite number of edges, then this is called finite graph, otherwise it is called infinite graph. So finite number of vertices A, B, C, D. So finite means what? Which we can able to count it. So we have finite number of vertices only, those are A, B, C, D. And if you observe the edges, we have E1, E2, E3, E4. So we have finite number of edges. So as we have finite number of vertices, finite number of edges, then we can say this graph is called finite graph. So next we also have weighted graph. So what is weighted graph here is a graph in which weights or numerical values are assigned to each of the edge. So now if we observe this figure, we have the vertices for this figure. Those are vertex 1, vertex 2, vertex 3 and vertex 4. So altogether how many vertices we have here? 4 vertices we have. So for this, what is V of G here? Mod V of G is 4, which is nothing but order. So mod E of G is here. So you need to count the number of edges. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 we have. Now if you observe carefully here, for each edge one value is assigned here. And that value we can say that is a numerical value, and that value we can say that it is called the weight of the particular edge. So like this, if you have weights for all the edges in that particular graph, and that graph we can call it as weighted graph. So means which is nothing but some value we are assigning to the graph. So for each and every edge we are assigning some value here. So that's why we can say that this particular graph is called weighted graph. In the same way we have cyclic graph. So what is cyclic graph here? If a graph consists of a single cycle, then it is called cyclic graph or cycle graph. So basically what is meant by cyclic? So starting point and ending point must be same. So this is starting point, again it has to move to towards the end point only. So source and destination are same here, then I can say this is called a cycle. So if a graph consists of a single cycle, so if it in a graph we have a single cycle where the starting and ending points are same, then we can say that is called cyclic graph or cycle graph. A graph with no cycle, let us suppose I don't have any cycle, which is nothing but starting and ending points are not same in the graph, then I can say that this is called acyclic graph. So here I have A, B, C. So A to B, B to C, C to A. So we have the cycle, why? Because starting point is A, again ending point is also same. Then I can say this is called cyclic graph. And here starting and ending points are not same, why? Because I don't matching here. Let us suppose this is A, B and C. A to B, B to C, but I am not giving C to A here connection. Then starting and ending are not same here. As the source and destination points are not same, then this is called acyclic graph. So in the same way we have trivial graph also. A graph which contains only one vertex and no edges, then the graph is known as trivial graph. Means only vertex will be there. Let us suppose this is vertex V1 and no edges we have. So then this graph is called trivial graph. So here, so only one vertex. So in the previous one, so we may have some confusion between this null graph and trivial graph. So here in the trivial graph, you should have only one vertex. So not no more than that. And no edges are there in that. That is called trivial. But in the null graph, a graph said to be null graph if it has no edges. If it has no edges means what? It can have any number of vertices. V1, V2, V3. Like this, I can have any number of vertices, but no edges here. So that's why it is null graph. But in the trivial graph, you should consist of only one vertex and no edges. Then the graph is called trivial graph. So what we have discussed today in this session is what is meant by graph theory. So what is the definition of the graph and what are the types of graphs we have discussed. Still we have a few types of the graphs that will be continued in the next session. So by this we'll end the session. Thank you.